you've had a good rest and managed to kind of get all of the new knowledge and new training in from the first couple of days in, and are ready for the climax of this course. Day 3 is a little bit different to the first couple of days. I should introduce myself. My name is Phil Yules. I work at Secura Labs, and I am a lead developer advocate for Nextflow and Nfcor. So I try and look after the communities and try and stimulate growth and make sure that everyone has a good time and basically make the coding experience as good as possible for you guys. I'm also the co-founder of Nfcor, and I've been writing pipelines for Nextflow for, I don't know, lots of years now. One of the early adopters in Sweden. So today is a little bit different to the first couple of days. Monday and Tuesday, we really kind of focused on getting Nextflow training, core concepts of the language, of how to write Nextflow and how everything fits together. And today we're going to look at Nfcor, so what Nfcor is, how the community is, and how it's different to Nextflow. And then we're going to talk a little bit about some of the tooling that's available through Nfcor, and work through some material on how to create pipelines from the Nfcor template using Nfcor tooling. Then there'll be a bit of a break, and Harshal Patel, who's from the Nfcor core team, will jump in, and he will take you through the wonderful world of DSL2 modules, Nfcor modules, which are kind of shared subparts of pipelines and how to build pipelines using that. Finally, we'll wrap up with Evan Floden, the CEO of Secura Labs, who will talk about Nextflow Tower, which is the kind of final kind of icing on the cake, really, of this whole Nextflow ecosystem. So you started off the first 2 days with the core of Nextflow, adding a layer of Nfcor, and then Evan will finish with a layer of Nextflow Tower. Just a quick mention about a couple of things while I've got everyone's attention. So we originally planned this training as a lead-in to the Nextflow Summit and the Nfcor Hackathon, which is kicking off next week. So if you haven't already been spammed enough by us about this and haven't seen this, do drop over to summit.nextflow.io to see the details. It's too late to register for in-person, of course, but you can still register to attend online for both the summit and the hackathon. But make sure you register pretty quickly if you want to join. That will close on Friday. But you'll be able to follow both the summit and the hackathon online. And if you go to the Nfcor website, you'll find go to events, you'll find more details about the hackathon. And that's really what we're like, really keen to get as many new faces into the hackathon as possible. And that's a perfect way to take all this training that you've done and kind of spend some dedicated time to get to grips and actually do something with it. And so if you go to the Nfcor website, you'll find all the details of how it works and how to join and what the groups will be. One other notification about something similar but slightly different is the Nfcor and Nextflow mentorships. This is done through funding with the Chan Zuckerberg Initiative, thanks to them. We've done 1 round of mentorships already, and we've just opened applications for round 2. That's both for mentees, so people who'd be trained, it's free for them, and also for mentors, and that's a paid position, so you'll get a small stipend for helping out with that. The first round went really, really well. You can check out, there's a blog post that we wrote which goes through the different pairs and the kinds of things they worked on, and we were really, really happy with that. Round 2 is twice the size. We're going to take on 10 mentors and 10 mentees. So please do have a look if you're interested. Closing date is November the 1st for applications. Right, so if you go to the training page on the Nfcor website for this training, back to now, we've got the schedule with all the streaming links and everything. You'll see that we've got a couple of links which are slightly different for this section. We're using a different Git pod environment for all the stuff with Nfcor. When Evan comes on last, he'll go back to the original one from the first couple of days. But for when me and Harshal are talking, we're going to be using a new Git pod environment. And we also have slightly different written training material. So if you follow that link, then you can find everything I'm going to talk about is all written down here. You can follow through at your own speed. If you didn't catch what I said, if I said it too quickly, you can hopefully sort of keep track of where we are in this written material. And importantly, there's the big launch Git pod button. So feel free to go ahead and hit that now and get that spinning up. And these are linked to within Slack as well. Okay. So I'm going to start today with just a few slides. going through an introduction to Nfcor for those of you who are new to the community, just to give you a flavour for who we are and what we're doing here. And then I'll dig into some more hands-on stuff. So to recap what you've been going over the past couple of days, let's just try and describe exactly what Nextflow is. So Nextflow provides you with this language to write workflows and pipelines in. Those are based up of kind of the singular unit within those are processes. They're connected with channels, and the whole thing is encapsulated within workflows. Those processes, Nextflow gives you implicit parallelization, so everything can run in parallel where it can without you having to worry about it. Nextflow gives you the ability to resume a pipeline. It gives you reentrancy, so you can kick off wherever you restart, wherever you kind of stopped if the pipeline crashes halfway through or something. And it also gives you reusability, that you can rerun the same pipeline and get the same thing again. Underneath that kind of language level, then Nextflow can also coordinate with a software level and a compute level. So with software, it has all the container images for all the packages within a pipeline, and you don't have to worry about installing all the tools that the pipeline runs. And with compute, it can interact with HPC, schedulers, local servers, and cloud. So again, the pipeline code doesn't need to have anything specific about your infrastructure. And then Nextflow also handles integration with code repositories for the pipeline code itself. None of this should be new. You've been going into this in a lot of detail the last couple of days, and the key take home really from all of this is that Nextflow is reproducible and portable, and hopefully you're well on board with this now. So that's Nextflow. What's Nfcor? Nfcor, this is kind of our tagline, a community effort. Just because you can do all of those things with Nextflow, you can make the Nextflow pipeline super reproducible and really portable. It doesn't, at the end of the day, it's a coding language. So if you write a Nextflow pipeline and you hard code a file path on your system, it's not going to be portable to someone else. And if you handle all the software dependencies in such a way that software versions are not pinned and things like that, then the pipeline is not going to be reproducible. So Nfcor kind of came out as a community project that sits alongside Nextflow. We're distinct, but there's a lot of overlap. And it came out of this desire to kind of establish a set of best practices. And also because it's possible to collaborate and share workflows, instead of everyone building their own RNA-seq pipeline that does pretty much the same thing, the hope is we can come together and work together on a single gold standard pipeline. And that's why Nfcor has one pipeline per analysis or data type. So it's a community effort, build a curated set of analysis pipelines. What does Nfcor give you? It gives you the pipelines which are ready to run off the shelf. So you want to run with the TAG-seq or ChIP-seq, or you have your data type, you can see if there's a pipeline already written and you can use it. Simple. You don't need to know very much about Nextflow in order to do that, really, just how to configure it. But beyond that, we also have a lot of tooling, kind of almost like third-party tooling, I guess. You don't need any of it to run the Nextflow pipelines. All you really need for that is Nextflow. But these tools, the Nfcor tools, make it easier for you to run pipelines as an end user, and also make it much easier to develop Nextflow code. Finally, what Harshal's going to talk about in his section is this idea of modules, which is a fairly new thing to Nfcor, which is kind of collaboration and sharing of pipeline code, but not on a whole pipeline level, but on a single unit level. And this is something which has really exploded within Nfcor the last year or so, and is now really a major selling feature for using Nfcor. Something I think I should probably make more of a big deal about, because it's not clear to everyone right away. Nfcor, we have Nfcor pipelines, but especially the tools and the modules here, these are for anyone with any Nextflow pipeline. And we actively encourage people to build pipelines using this stuff, even if you never intend to put it onto Nfcor. Even if it's internal only and private, even if it's so specific, even if you're just testing and playing around with stuff, you can still use these tools. You can still use the Nfcor template. You can still use all the DSL2 modules and collaborate on a module level. And it's very much encouraged. So please don't be put off by thinking, well, I don't ever want this pipeline to be part of Nfcor on the Nfcor website. That's fine. This is all still super relevant. Final point about the community, if you're kind of familiar to kind of other places which host pipelines or code, It's important to point out that we operate in a slightly different way. We're not a code repository. So it's not the kind of thing where you can turn up with a pipeline that you've written and ask for it to be put onto Nfcor. We kind of really ask you not to do that. We want you to come with an idea for a pipeline, tell us about it, check that everyone agrees it's a good idea to be put into Nfcor in the long run, and then maybe even find some collaborators or see someone else who's already proposed the same idea and work together with the community from the get-go. There's a couple of other things which are quite specific. We insist that you use the Nfcor template if you're going to work with Nfcor, and that's for lots of reasons. Standardization is a really big part of what we do, and much of the tooling we do is based around this idea of kind of common boilerplate code. Excuse me, there we go. And then finally, this idea that we only have one pipeline per data type. So if you come in and say, the RNA-seq pipeline doesn't do what I want it to do, I'm going to build a new pipeline that does this, we'll say no. And we'll say, please go to the existing pipeline and add on that functionality. So that way that anyone coming into the Nfcor community doesn't have to choose between pipelines. They just look up the data type they have, and it's very obvious which pipeline they should use. So if you look at what pipelines are available to use today, if you go and check out the Nfcor website, you'll see a big list. There's 39 which are released, and the release with the little green tick is important because this is the main quality control check for the Nfcor community. So to get your first release with Nfcor, you have to go through a lot of code review. And this is where we really make sure that that pipeline does indeed adhere to the best practices and the guidelines that we lay out. So once the pipeline's got a first stable release, you can be confident that it's kind of best practices. We also have a lot of pipelines under development, which don't have a first release, and they range from very early development through to pretty complete pipelines, which may well be in use in production, but just haven't quite got through that first review. So still lots of usable code there. And then some pipelines are archived. This is usually if the functionality that pipeline provided has been brought into another pipeline, or if it's outdated and it's just never going to be updated again. We archive it, we never delete things. That way, people who used that pipeline in the past can still go back and reuse it for reproducibility. I mentioned these DSO2 modules. These are more numerous because yesterday and day one and day two, you had, for example, a process with salmon index to build a reference index. So that would be a module, is a module. And then salmon, you can have an alignment step, and that would be another module. So each individual process level gets wrapped up into the DSL2 module. And we have this massive library, which has just grown like crazy the last year or so and shows no sign of slowing down. So many common bioinformatics tools are already there. And that means you can assemble a pipeline very fast. This is a really strong selling point. But Harsha will talk about this in much more detail. So if you go to the Nfcor website, you will see a big old list of pipelines, and you can pick through, and there's a similar page for modules. So we started Nfcor around 2018, and we've had a really steady kind of increase in community size since then. This is the visitor statistics to the website. You can see a little kick just at the far right there. That's this training. So thank you everyone who's been coming and checking out the Nfcor website. And basically shows kind of no sign of slowing down at this point. We have over 3,500 people on the Nfcor Slack, which is crazy. So pretty much any time of day and night you have your problem with your pipeline, you'll find someone lurking on the Nfcor Slack, and you'll be able to get help. And this is really one of the key selling points for Nfcor. Had nearly 1,500 people now who've actively contributed to at least one pipeline, be it through writing code or creating issues, bug reports, things like this. So the community is really big and is really growing fast still, which is super exciting. We are spread now pretty much all over the world. We started off in Europe. That's where Nextflow started, and much of the initial community kicked off, but we've got a strong presence in Americas now, and also increasingly in Asia and Australasia. So, but we're really interested in kind of increasing the inclusivity of the community and geographic kind of spread. This is part of the reason we're doing things like the mentorships with CSI, and also Marcel, who you heard from yesterday, is based in Brazil. He's a developer advocate, So he's really trying to get more people interested and excited about Nextflow down in South America. And Chris, who ran the training sessions in the APAC time zone, is trying to get people on board in Australasia and Asia. So please do try and spread the word, but we're really excited with the way that this is going. Right, final thing in my slides is just to mention that there is a pipeline, came out in 2020. Parts of it are a bit dated now, but if you're curious about how we built the community and why we did things in the way we did, it's quite a good read. I'm a bit biased, but and the supplemental materials have quite a lot of detail on how we set up the back end of a community, which could be interesting, especially if you're thinking you're doing something similar. So yeah, check it out. With that, let's get stuck in and actually do some coding. So big green button, quite a long link, but like I said, there's an easier way to find it through the event page, and I think it's linked to in Slack. So you can click launch Gitpod, and then you can launch Gitpod either in your web browser, or what I've done is I have it connected to my local installation of VS Code, which should be exactly the same, but I just prefer it slightly. And so now I am logged into Gitpod. Note that this is a different Gitpod to the one we were using the first couple of days. We've been doing some quite intense work on Nfcor tools right up until the last minute, by which I mean, yeah, less than 24 hours ago. We were up late pushing a version 2.6 release of Nfcor tools. That will usher in additional functionality. It's paving the way for sub workflows, which are going to be a huge thing for Nfcor. More on that later. So as a result, we wanted the latest bleeding edge version of this software for you guys. So we're using a slightly different Gitpod environment. So check that out. And when Evan comes on later, he'll be back in the original one. So the first thing I'm going to do, this Gitpod environment is based on the Nfcor tools repository, and there's a load of files here on the left-hand side that I basically don't really care about. So, sorry, I'm just going to move that browser window out here so I can follow the materials myself. So the first thing I'm going to do is I'm going to bring up the terminal here, full size, and Harsha, you need to mute yourself on Zoom. And we're going to make a new directory for myself. So I'm going to go to my home directory, and I'm going to make the training, and going to go into the new training directory. I'm going to do pwd, find my current working directory, and I'm going to grab that. I'm going to go into file and open folder. If you're doing this in the web browser, it's like a little kind of burger icon just above the Explorer. You should be able to find file through the same place. And there's a shortcut key as well, which depends a little bit on your operating system. But open folder, you should get to a dialog that looks like this. And I'll paste that in, and then VS Code is going to reload. Yes, I trust the authors. Great. So now on the left, we've got no files here, which is good. If things are ever slow, you can hit that button to refresh the file explorer. But there's nothing there. There's nothing in this folder, so unsurprising. Great. Okay, so we've got a slightly cleaner environment to work on. This Gitpod environment, like I said, comes with Nfcor pre-installed and also Nextflow. If I look at Nfcor version, I can see that we've got version 2.6. And if I do Nextflow info, we can see that I think it's Nextflow, yeah, 22.04. If you are installing Nextflow, these tools yourself, Nfcor tools especially, is actually written in Python. So it's not Groovy or anything like that. And it's available through the Python package index here. So you can just do pip install Nfcor. It's also on Bioconda. So you could do conda install Nfcor if you've got Bioconda channels and everything set up properly. So you can install it pretty much however you like with typical Python packaging. There is a Docker container, but I would avoid that for now for this tutorial, if that's okay. Great. So hopefully you can follow this along either in Gitpod or locally. So if we look at Nfcor help, -- help, get an overview of all the different commands which are available here. So this is kind of broken up into a couple of sections here. You've got different subcommands available for people running pipelines, for users. And then you've got commands available for developers. Most of the time we're going to spend on this bit. But just to kind of point this out, we've got Nfcor list, for example, which gives you all the available Nfcor pipelines. It's the same as the website page, basically. But the key difference here is if I do Nextflow pull Nfcor RNA-seq, so Nextflow grabs this copy of the public GitHub repository for me. It was doing the same thing as if I did Nextflow run Nfcor RNA-seq just without actually running it. So it's going to fetch a copy for me. And then if I do Nfcor list again, we can now see that it tells me I've just pulled this copy of this pipeline. So if it could also say a week ago or 6 months ago. And it also tells me that it is running the latest release of Nfcor. So this is quite useful just to keep an overview of which pipelines you have locally and whether you need to update them. And also on the kind of user front, we've got things like Nfcor download, which is good for anyone running on a system which is totally disconnected from the web. You can run Nfcor download to fetch a pipeline and its configs, and if you want all the Singularity images, so that you can then transfer that onto your system. That's used a lot. And Nfcor launch, which gives a graphical interface for launching pipelines where you can fill in all of the different parameters, and that shows you kind of help text as you go along and validates the inputs as you go along and stuff. And we'll touch on that a bit more later. But what we're really interested in right now is creating a new pipeline. So I'm going to go right ahead and I'm going to do Nfcor. I'll do clear this. Oops. I'm going to do Nfcor create. Most of the Nfcor subcommands and commands, you can give command line flags to make them run. But if you don't give them any flags, they will prompt you for stuff as you go along. So generally, when you're running interactively like this, I would say just do Nfcor create and it will tell you what to do. One of the benefits of this is you get kind of inline validation. So if I do, this is a rubbish name, then it's going to tell me I can't call my pipeline that, which is probably for my own good. So I'm going to call this one demo. I'm going to say that my name. With the newer versions of Nfcor, you can choose to make a pipeline without, for example, the Nfcor logo and branding. If it's not a genomics pipeline, you can choose not to have reference genomes and things. And so this is quite a nice new feature for those of you, especially working kind of slightly outside the realms of Nfcor. You can choose which parts of a template you use. I'm not going to do that right now. I'm just going to say, no, give me the full pipeline. But it's good to know it's there. Right, so it's created a folder for me, Nfcor demo, and it's even told me what commands I should run next in order to get my code up onto GitHub. And it also reminds me that I shouldn't go ahead and start writing a pipeline. I should go and join the community first. So if I look in this folder up here on the left, there's a lot of files it's created. And I'll walk through some of those quite quickly. But the first thing I want to point out, if I cd into the directory here, is that this is like a fully fledged Git repository already. If I do git status, you can see it's kind of tracked. I can do git branch, and you can see that we've got the 3 branches that Nfcor always works with. When you run a pipeline of Nextflow run URL or GitHub repository, it fetches the default branch. So what we do in Nfcor is we say that the default branch is master, and that should always have the latest stable release. So if people don't specify a version, it gets the latest stable release. And all of the development work happens on dev, and the template branch is used for automated template synchronization. So if I do git log, the way this works is that when I created the pipeline, it automatically made a first initial commit, which is shared across these branches. And this has the pipeline template in it, which is completely unmodified. The template branch you never touch. You carry on developing on dev and master, but when there's a new release of Nfcor tools with a new version of a template, where we have automation within GitHub Actions, which creates a new commit on the template branch with a new updated version of just the template. And so Git knows what's changed between those versions of a template, and then it sets up an automatic pull request coming into dev, which hopefully brings over just the changes that have happened within the template and leaves all of your custom code unaffected, in theory. So that's what this branch is, and that's why you shouldn't touch it. And then you see here also, so it tells you you can push to a remote. So if you go to GitHub, you can click new repository. Remember not to click initiate with a README or anything. You just want it blank because we've already got the first commit here. So you can add your new remotes that you've created online and then do git push. And remember to do git push -- all so that you get all 3 of these branches up onto the web. Okay, great. So Nfcor sets you up properly with Git, with all this kind of configuration. What else have we got in here? Some of these files in here you will never need to touch, and some of them are kind of obviously where you're going to write your pipeline. So we've got files like here, PyProject, Prettier, things like this, which are basically configuration files, which you shouldn't need to touch. Some of these are auto-generated, these files, like the schema and JSON, which you shouldn't need to edit manually. And some of these things like lib just have kind of core boilerplate Nfcor code, which again, you shouldn't need to touch. In bin, we have scripts used by your pipeline. And in assets, we've got things like the test data sample sheet. So these have some files you might want to edit. Conf has lots because you're going to have to come in here to change the base.config, which has all the defaults for how things should run. And they've also got the modules.config, which is how you use the DSL2 modules, which Harsha will come on to talk about. And then in documentation, we've got docs. We've got these files you should kind of work on as you go along to make sure that your pipeline's got really top level documentation. And then this is where all of the DSL2 modules get put into. And then finally, the main meat of your pipeline is within the workflows directory. And this is kind of pulled in by main.nf. Here, main.nf is quite short, but the main workflows end up in here. So that's a very brief outline of the files that we've got created here. Just to kind of prove to you that this is a real functioning pipeline right away before I've done anything, I can try and run it. So if I go up a directory here, I can do Nextflow run, give it the directory path here, which is Nfcor demo. Say -profile test. So that uses we have a specific test config file, which is within the profile scope. So if I do -profile test, it pulls all that in, and that has all of the parameters for the pipeline that are required in order to test it, including input data and other things. This is one of the things you will need to build as you build your pipeline. And I'm going to say run it with Docker, which we have on Gitpod. And I'm going to say out there test run. So that's going to kick off, and that's going to load this new pipeline and hopefully run it for us. So we can see the files starting to pop up here. As it goes, it's going to start telling us about how it's run. It's got things like the version of the pipeline. So we've started on version 1 because it's a new pipeline. Every time you do a GitHub release, you update this in the pipeline, it'll be reflected here. It shows us some of the variables which you should be familiar with from the past couple of days, things like project dir, where the pipeline is, launch dir, where I'm running it from. And then it shows me which parameters have been changed versus the default for the pipeline. So these have all been set by the -profile test, basically, apart from out dir, which I set myself manually. And then off it goes. You can see it's running some processes down here. It's checked for the sample sheet, which came with the pipeline, which is for the test profile. And it's now running fastqc on a bunch of very small files. Obviously, these processes themselves are not super meaningful. You might be building a pipeline that has nothing to do with genomics, in which case running genomics tests doesn't really make any sense. It's just a starting point. Don't overthink too much what's actually being run here. You can remove these processes, these modules. You can remove this test data and replace it with something which is more appropriate to you. It's just that there's some holding content there, so you know what's accepted. And if we look in the test run folder, we can see the output files being generated. We've got our fastqc results in here. There you go, multi-QC is finished. We've got a multi-QC report. We've got our pipeline reports here. So it's nice HTML files and things. And we can see down here that we've finished. So we're off to a good start. Everything is working so far. And that means if I do another demo later and it breaks, it's my fault. Right, so we have a lot of people within Nfcor and a lot of people working on pipeline code, and they might be coming from different backgrounds, different places. have very different tastes in what they're used to in terms of writing code. So how do we maintain kind of quality and standardization across all of these different hundreds of people? We use automation a lot, and we use automated code quality checkers. And these basically come in kind of two flavors. The simpler ones are just looking at code formatting. And this is important because we want to reduce the kind of non-meaningful differences. Makes it much easier to review pull requests if the only changes there are just the actual code that people have changed rather than loads of white space that's been changed all over the place. And it just makes it much easier to read the code. It's one of these things, once you start using code linters and formatters, it's difficult to work without them. And so we use Black for Python code, which is kind of the most common one for Python. And we use a tool called Prettier. This is the logo down here, which does YAML and JSON markdown and stuff. So to kind of show this in real life, we can open a markdown file here. And you can see I've got some regular markdown here. I can start deleting things and removing white space. Maybe I can make a list and just call every bullet point 1, 2, 3, things like this. This is valid markdown. This will render no problem to HTML. However, the formatting and all the syntax here is not standardized. So what happens is we've got Prettier. I've got it installed as a plugin in my code editor here in VS Code, and hopefully it worked the first time I did it this morning. It didn't work the last time, but hopefully I'm going to hit Command S to save a file, and Prettier will run, analyze this file, realize that there's some problems with it, and fix them for me automatically without me having to touch anything. So what I'm going to do is save a file. In fact, I'll do it up here so you can see file save, and there you go. Oops, it's put in the extra white space back around here. I didn't renumber it. Why is that not working? If I do something random like that, what happens? There you go. Okay, so 111 is allowed, but not non-sequential numbers. So now all your lists get automatically fixed. If you've got markdown tables, they get automatically readjusted, or things like this. So it saves you a lot of time when you're writing code. It means you don't have to think about this kind of stuff, whether to use single or double quotes. It just happens automatically. And helps us because it makes it easier to review code. So those are the code linters, the code formatters. A linter is just a tool which checks other code. And then we also have one which is written specifically for Nfcor. And this is kind of custom written by us, and it has a whole load of checks which check the code quality to make sure that you haven't done something within your pipeline which kind of violates any of the Nfcor guidelines. You haven't deleted or edited a file which shouldn't be deleted or edited, things like that. So let's have a look at some of the things that they might do. One of the most obvious ones you'll come across straight away is one that looks for to-do statements. Now, the reason we have these is that when you look at this new pipeline that's being created, it's great that it does so much work for you, but it's also kind of overwhelming, especially if you're not used to looking at pipelines like this. There's lots of files, there's loads of stuff, and like, where do you start? So what we've done to help you get started is if you start looking in a config file, for example, I think I saw one up here. There you go. You've got these code comments lurking in here that say to do Nfcor. This is highlighted in orange because I've got a plugin in VS Code which is doing it. It's just a regular code comment. If I change it like that, it goes back to the normal coloring. But it just kind of flags. We've got little flags here saying this is something that you should probably do or check or whatever. And you can work your way through all the files in the pipeline looking for these. And when you're happy that this is done and customized, you just delete the comment line. Because we use these kind of to-do comments, you can also use plugins like this to give you an overview of the whole kind of the whole pipeline. And I think this needs to scan the entire workspace, so it's not showing all of them at the moment. But this to-do tree plugin in VS Code will give you a complete list of all the to-do comments, and you can just work your way through them, ticking them all off one at a time. It's quite easy for you to miss these, and maybe we've updated the pipeline and we've got a new part you should customize as a new to-do comment. So one of the things that we check for is we look at all the files. So I'm going to run Nfcor lint on the pipeline here, hit enter, and it's going to look at all my pipeline and try and see if it's up to scratch. It's going to be a little bit slow on the first run because it's fetching some files off the web for DSL2 modules, and it's also collecting all of the Nextflow config and stuff. So the next time I run it, it'll be a bit quicker, and it spits out all this output. So we've got tests at module and pipeline level. I'm going to ignore these for now. This has been fixed already. So the next release of tools, there won't be any warnings for modules. But for pipelines, you can see I've got a bunch of warnings here. And sure enough, these are all the to-do strings I mentioned. So if I had missed any, they'd be super obvious to find via this. I can cheat slightly and don't do this, but I'm going to find all the occurrences of to-do and replace them with demo, so that I no longer have any Nfcor to-do statements. And now if I run Nfcor lint again, hopefully all of those warnings will have gone. Hopefully it'll be a little bit quicker as well. Yep, sure enough, there are no pipeline warnings left. The number of past tests has gone up, and the number of warnings has gone down a lot. So good news. So this gives you an idea of how this works. Warnings are kind of tolerated. They're okay. You should try and fix them up before you release your code, but they're kind of okay as you go along. So they're not a deal breaker. However, if you get failures, those are something that needs to be fixed. I can give you an example of that. This is the Nfcor code of conduct. So typically for an Nfcor pipeline, it's something you shouldn't edit. And so I'm going to break the rules, and I'm going to edit this file. Now, if I run Nfcor linting, it should give me an error. There we go. A couple of things to note here. It tells me what's wrong, which is useful. And it also has this key here. And this name in the pipeline linting goes to it's basically a unique identifier. If you're running this locally on your computer, you should be able to alt-click this, and it is the hyperlink that you'll be able to open in a web browser to get documentation. It doesn't work so well in Gitpod, unfortunately. But I can try and quickly show you where it goes to anyway. So if I go to Nfcor tools, docs latest, there we go, pipeline lint tests. So it would have dropped me straight into this web page, but you can also find it yourself manually if you want. And you can see that this is documentation about specifically this lint test. It tells me all of the files which should be unchanged, and these files I can add stuff to the bottom. So when you get your failures, it's pretty quick to go in and try and figure out what's going on and fix them. Importantly, when you have a failure, it also gives you a system exit code of 1, which is bad. And this means that we can use these lint tests for automated tests, for continuous integration automated tests. What I mean by that, if I go to a small RNA-seq pipeline, I'm going to pick on Alex because you won't mind. I go to a pull request that Alex has created here about adding something in. And if I scroll right down to the bottom, you'll see that there are a bunch of automated tests that run on GitHub using GitHub Actions. Some of them have failed, so it's trying to run the pipeline with some test data, and that's not worked. So it's got a red cross, it's failed, and some have succeeded. Some of them have got this green tick. And sure enough, there's one called Nfcor linting at Nfcor. It's passed, and I can click on details here and see exactly what it has run. Go to Nfcor, click run Nfcor lint, and you see exactly the same output that we've just been looking at with warnings and things. This was a pass, so there's no failures, which is nice. So this means when you create a pull request for an Nfcor pipeline, this automation runs, and anyone who's reviewing the code will see a little red X straight away if anything's wrong. And it just makes sure that we don't miss things, which would be maybe easy to miss in big pull requests and things. It also helps you because you know what's wrong before you bother putting in a submission, and hopefully kind of means that that kind of cycle of fixing things is much, much quicker. Sometimes, last thing on this, sometimes it might be, you might have a good reason why you want to edit this file. Maybe you want to delete this file. You're not part of Nfcor, you don't care about the code of conduct. Or whatever else. There's some lint test which is failing, but you don't mind. Thankfully you're able to customize Nfcor linting, because otherwise this would always fail and you'd just never be able to use this test. But we have this .nfcor YAML file which sits in the root of every directory, and we can put in this config file that we want to ignore certain tests. So I'm just going to copy this from the docs that I might have got on the side. I can say for linting, I want to take the lint test called pipeline to-dos, and I'm going to set that to false, which means I just don't want to run that test at all. And then for the pipeline test called files unchanged here, I want to ignore specifically this file. But the tests change a little bit on how much you can customize them. I could just write false and skip the entire test. But I'm going to skip specifically this file so that it continues checking all the other files. So if I save that, rerun Nfcor lint, then everything should be fine. We've got some ignored tests, but we don't have any failures anymore. Great. Hopefully everyone is still kind of with me at this point. Hopefully someone would have told me by now if the streaming wasn't working or if you couldn't see my screen. We're going to change tack ever so slightly now. I'm going to move on to my next topic, which is talking about Nextflow parameters. So just to give you an example of what I'm talking about, if I run Nextflow run and I give it the pipeline name, and I can do -- help, and I can do this with any Nfcor pipeline, and it treats it. It runs the Nextflow pipeline, but it just spits out some usage help and an exit straight away. And when I do this, it will tell me about the core command line options that this pipeline has. And what I should have done, and I forget every time I do this, is I should also do it with -- show hidden params, which shows the full list, including all the boilerplate ones, which are usually a bit boring, which most users wouldn't want to change. But what you can see in this output here is that we've got a typical pipeline command, and then we've got all these parameters. And if you remember looking at the Nextflow config file, when you set these things, they're just kind of strings or numbers or whatever. There's no additional content here about the type of that parameter. There's no help text or description or anything. But here on our help output here, we have this kind of information: typing, defaults. We've got descriptions, and it's even grouped. We've got booleans, all kinds of things here. So how do we do that? There's no way to do it within the Nextflow config file as of yet. So what we did was we set up a new kind of standard within Nfcor, which is now sort of spread to all of Nextflow really. And we created this new file called a Nextflow schema file. And this follows JSON schema, which is a sort of standard structure for JSON files of this type. And it means that we can define our properties, which are our parameters here. So -- input should be type string. And then if we scroll down a bit further, if we can find a Boolean, here we go. So IG names ignore is type Boolean. We've got our short text descriptions, and we've got our help text and everything all hidden within this JSON file. And this is what's being used. This is really, really helpful because this additional information means that we can do a whole bunch of stuff. We can print help text like this. We can also render website documentation. So if you go to any Nfcor pipeline page, you'll see a tab that says parameters. And this uses the same JSON file to give us kind of nice, rich help text. We can use it to build kind of graphical interfaces. So you can launch pipelines on the website using this form to input all of these different parameters in a rich way. Evan will talk about Nextflow Tower later, which has a similar kind of infrastructure. So it lets this third-party kind of ecosystem of tools use parameters in a more effective way. And really importantly, it also allows us to validate inputs from the end user right away. So if I do Nextflow run, just like I did before when the whole pipeline ran, but this time I'm going to remove the out dir at the end, which is a required parameter. I'm just going to run it without that. And the JSON schema says that the -- out dir is a required parameter. So right away, Nextflow exits before it does anything. And this idea of failing fast is really, really useful. Before we had this, your pipeline would either run silently and not do things you wanted it to, or it would run halfway through the pipeline and then crash. So instant validation of parameters is a really helpful thing. Right. Now, some of you, when I showed that schema file, you might have come out in a bit of a light sweat. This is a big JSON file. And we've only just started work on our pipeline. And already we have 280 lines of JSON, very complex, deeply nested, specific keys and everything. It doesn't look nice to edit. And the good news is you should not edit it by hand. If you're looking at this file in a text editor, generally something has gone badly wrong. We have written tooling around Nfcor and the Nfcor schema so that you never need to really touch this by hand, and we can kind of handle it all through a nice graphical interface. Now, to demo this, I'm going to go into my Nextflow config file here, and I'm just going to add some new parameters. So I've got one called a demo, which is a string. I've got my nice Boolean here, and I've got a number. So nothing really special about this. But of course, they're not in my JSON schema file yet. So I go back into the pipeline directory. I could do minus help. There is a subcommand here called schema, which is dedicated to working with Nextflow schemas. And I can do, if I do minus help on, something went weird with Gitpod then. Minus help on schema, you can see there's also subcommands under here. The one that we're really interested in now is called build. So I'm going to do Nfcor schema build. Now this spits out all the parameters from Nextflow pipeline using Nextflow, and it compares them to the JSON file first and checks if there's any mismatch. So here we've got some new parameters from the Nextflow pipeline, and it said, do we want to add these to a JSON file? Yes. Great. And straight away that has updated our Nextflow schema file. If I look in Git changes here, I should hopefully be able to find the, yeah, no, there it is. Here, if I scroll down to the bottom, we should see, there we go. Here are our new properties that have been added into the bottom of the file. Doesn't say very much about them yet, but they are there. So we're off to a good start. Next, it says, do I want to launch a web builder to customize that? Yes, I do. Right, this is a bit weird. This is a Gitpod thing. Normally, at this point, the command line tools would kick off a browser window, but Gitpod doesn't really know what browsers you have installed and things like that. So it tries to be clever, and it uses Lynx, which is a command line browser, web browser, but we don't want to do that because that'd be a nightmare. So I'm going to press Q to exit out of this. Yes, I want to exit. Okay, this is what it normally looks like. Thankfully, it gives us a URL here that we can copy out, which might also be useful if you're running on a remote system or something like that. You can open this web URL wherever. You can open it on your phone if you want to. Right, so I'm going to pop this URL into my web browser here and have a look. So here we have all of the different parameters from the schema in a graphical editing interface. I'm just going to collapse all of these groups, and you can see the new ones down here at the bottom. I can make new groups, so I call this demo group, and if I zoom out a little bit, I can also drag and drop these around to reorder them. So I'm going to drag my new group down to the bottom here, and then I can pick up parameters and drag them into the group or between groups or whatever. If you have lots of parameters, it's usually quicker to click this magic button over here, which shows you ungrouped parameters, and you can kind of add them all in one go. And then I can still reorder them and everything. It's been a little bit clever. It spotted that this should probably be an integer, and sure enough, you can see this is a numeric field. It's got this wrong though. This has got a default string value of false, but we know it's a Boolean, so I'm going to click Boolean here. I'll zoom back in. So Boolean, and now we've got it can only be true or false. Can also write a description for all of these, a short description, and if I click here, I can write longer form help text. And it even gives me the option of previewing what it will look like on the command line and on the website. So this is a really good way to document all the parameters in your pipeline rather than writing super long markdown files. And I can also set icons, which is great for building graphical interfaces, be it help or launch interfaces. So I can pick a test tube and I don't know, hand sanitizer, some weight training bar or something, I don't know, whatever is relevant for your, feels relevant for your option. So this is how you get that kind of nice rich formatting of all your parameters. And it's worth spending some time on doing this because it really helps people running your pipeline. Importantly, I can tick if it's a required parameter, so the pipeline won't launch if it's not set. And I can also hide it from the default help options and stuff. There's also this button over here on settings, and this lets us do some extra kind of cool stuff. Booleans are kind of boring, so we can't really do anything with those, so there's no special settings. But if I go into integer field, you can see now I can set a minimum and a maximum value. And I can even do a list of enumerated values here. So I can say that this has to be set to either 2, 4, 6, 12, 24, separated by pipe characters. And now launch interfaces will probably show a drop-down box here. And if I try and set anything other than those values when I launch a pipeline, it will fail with a validation error. Strings have even more. If we go in, we can do enumerated values again, but I can also set regular expressions, which is a really flexible and powerful way to kind of sanitize and validate your inputs. So the example and the placeholder here would be to check that this is for a .csv file, so it has to end in .csv. If you're not used to regular expressions, you can get some help about that. This one is very new, so probably most people won't have seen it, called format. And this might be more things in the future, but for now is a way to define whether a parameter should be a file or a directory or either. If I select file path, it gives me some more fields. I can say what kind of file it is by its MIME type. You can, again, click here to get a big old list. But if it's a CSV file, I can do text CSV. This is a very new feature of the file schema. I'm not going to talk about that right now, but it's for validation of the files themselves. This is really useful for kind of tools which integrate with Nextflow and with Nfcor pipelines or Nextflow pipelines, because now Evan will touch on this later when he talks about Tower. Tower, for example, uses this to know that there is this parameter takes a data sheet or like a spreadsheet, and can give you really nice, rich interfaces around that. And you can imagine all kinds of different ways to use this information. Great. Okay. I'm just going to quickly minimize these windows so you can see what's going on. Oh, actually, I bet I can drop that in so it's a split screen. There we go. So this command that I ran is still running in the terminal here. The whole time it's just been sat there waiting in the background with a little spinner going round and round. When I'm finished, I can hit finished over in the web browser here, which is on the Nfcor website. And this will see that something has happened and will take the schema which is built on the website and save it in my pipeline, which I just think is super cool. And sure enough, if I go into Git, source control, and look at Nextflow schema, we should see all of the nice things that we've just been setting in a group. There we go. We've got the type information. We've got our enumerated values. All of this stuff has been saved into that JSON file for us. So really powerful and hopefully very easy to use way to set up customization of the parameters. And again, this works for any Nextflow pipeline. It doesn't have to be Nfcor. You can do these with the example scripts you were doing with the past couple of days. You still just do the Nfcor schema build. Right. With that, I am going to call it a day. We'll have a running over a little bit, so we're not really going to have much of a break. We'll have a couple of minutes break. And I'm going to hand over to Harshal, and Harshal's going to talk all about DSL2 modules, and they are amazing, powerful things. But I'm finished for the day. Thank you very much for watching, and hopefully I'll see some of you at the summit next week, be it online or in person. And if not that, please do join Slack, become an active member of the community. It's really fun, and Nfcor is a really powerful ecosystem. Hopefully I've convinced you of that. I'm going to jump in and see if there's any questions that I can help with now. But otherwise, yeah, join us back in a couple of minutes, and Harshal will continue talking about DSL2. Thanks very much.
Okay, so maybe we should get started. So thank you guys for tuning in today. It's the last session now of what's been a crazy few days for a number of people that have done amazingly well to put all of this together, and it's awesome working with a community like this where we have lots going for us and stuff. What I'm going to do is introduce you to Nfcor modules. It's essentially our way of compartmentalizing Nextflow workflows on Nfcor. But before I start doing that, I'd like to introduce myself as Harshal Patel. I'm Head of Scientific Development at Sakira Labs. I've been a long-term user of Nextflow and also contributing to Nfcor from the very early days. And it's just absolutely amazing how the framework has evolved and how it's grown over the years, and just the willingness for people to learn and get involved with the framework is phenomenal. So Nextflow, for those of you that don't know, Nextflow initially started with a DSL1 syntax. And so this was the syntax itself was the way that you write these workflows. It was quite monolithic in that you had to write everything in one big main script. So if you wanted to write a complex pipeline and reuse components within the pipeline, you had to physically copy the code in different places. And a couple of years ago, well, longer than a couple of years ago, at one of the community conferences, Paolo decided he wanted to implement the DSL2 version. It took a little bit of time to get it there. And eventually we ended up with a preview of DSL2, which then turned into a stable DSL2 release. So DSL2 in this context is mostly the ability to reuse components of Nextflow workflows. So say, for example, you write a process, which we would consider as a unit of Nextflow that you guys have probably learned over the past few days. The ability to reuse that process within the same workflow and other workflows in sort of an include type fashion that you do with sort of conventional programming languages is essentially what DSL2 is. And I'll explain some of this to you in a bit more detail. So this is what a typical workflow will look like. This is the Nfcor RNA-seq pipeline. It's one of the most popular workflows that we have on Nfcor, and it's probably also one of the most widely used, and that's partly because RNA-seq tends to be one of the most common sequencing protocols that scientists perform to figure out what's different between conditions in terms of gene expression. And so you can see there's a number of steps here where, say, FastQC, even in this one workflow, is being called before and after adapter trimming. And there's the key components of functionality here that potentially could be reused across Nfcor. In genomics, there are typically very common steps that are performed in pipelines up until a point where you do alignment, for example, and then after that, you tend to sort of diverge depending on the type of seq that you've performed. So for RNA-seq, you will do quantification. For ChIP-seq, you'll call peaks. For ATAC-seq, you'll call peaks. For DNA-seq, you'll call variants. And so up until a point, there's a lot of common functionality between pipelines. And the idea behind DSL2 and the fact that it became available was very appealing to Nfcor in general, because we have 60 or 70 pipelines now, and we would love to share functionality across these in a way where we maintain everything in a single location, and then these units are essentially installed within pipelines so we can reuse them. And another benefit of that is that you update these modules or these scripts in one location, and everyone benefits from that. And so we created this Git repository on GitHub called Nfcor modules, which at this point is just hosting module scripts. So a module in our definition is a unit of Nextflow. It's a single process that performs a particular task. And so, for example, that could be a module for FastQC that does QC on FastQ files. You can also have other modules for tools like, say, SAMtools index, which is a tool and a subcommand, but that does a particular task. Similarly, you can have one for BWA mem and so on. And so these modules have now accumulated on Nfcor modules over time. We've refined the way that we're using them. We've had some help from Paolo to help us adopt modules on Nfcor as well, which has been incredibly useful. And so at this point, Nfcor modules is just units. However, we are hoping to now extend this functionality out where we can also automate and have sub workflows that we can share between pipelines too. And so a sub workflow in our definition is a chain of modules. So say, for example, you have a simple sub workflow that sorts a BAM file, indexes it, and then runs a few stat steps on it at the end of it. That sub workflow can easily be called within the same workflow. So say, for example, you are sorting a BAM file multiple times within your workflow. You can easily just import and include and use that directly there. Or you can use it across workflows as well. I'm pretty sure most genomics workflows will be sorting a BAM file at some point. And so this becomes more powerful now because you're not only sharing individual units, but you're able to now plug chunks of functionality directly into pipelines and hopefully automate the way that this all works. A workflow is an end-to-end implementation, and so that would then just be a combination of modules and sub-workflows, like the RNA-seq pipeline is an end-to-end workflow. When we started discussing and going about figuring out how we will actually implement Nfcor modules a few years ago, we had to discuss some of the key requirements, because whatever we try to do on Nfcor, we try and do it properly first time round. It just means that it's less effort later and things are less prone to breakage. Although based on the fact that we had to update all of the modules last night and over the past couple of days, as well as release Nfcor tools, which in fairness wasn't actually our fault, because it just requires some foresight to incorporate sub workflows on Nfcor modules, which we've now done anyway. And so that'll be cool next week to work on the hackathon. But so there were some key requirements with Nfcor modules. They have to be reproducible. This is key to modules and also science in general. They have to be flexible, so users and developers can add and adjust them according to their needs in their different pipeline contexts. They need to be portable, which is partly due to Nextflow and its awesomeness in terms of running, with ease on different platforms. They needed to be standardized as well. So we tend to try and make things as simple as possible, which kind of leads to the last point there in terms of automation as well, because the more you standardize things, the more you can automate things. If you start using custom bits of logic and things get out of shape across a repository, then it becomes very difficult to automate updating things. And this was actually quite apparent when we had to update all 630 modules a day before this event. And we needed to do all of that restructuring in order to now go to the next step and start using sub workflows on Nfcor modules. But if things weren't standardized, then this would have been a lot trickier and a lot more difficult to do. And also documentation is key. It's something that's very close to our hearts on Nfcor. We love documentation for everything. It just makes things more transparent, easier to find, and easier to use as well. And so all of these things kind of came together. The way that we've adopted Nfcor modules has evolved over time. We've got better and better with the syntax. It's been rolled out across more pipelines on Nfcor as well, where we're able to share this functionality. And now we've got 632 modules, 150 odd contributors, and it's growing very, very fast. And it's amazing because anyone in the Nextflow community, in fact, can leverage from these modules and just directly install them in their pipelines, as I'll show you in a second. So sub workflows is something that will be coming soon. It's going to be one of the key topics of the hackathon that we have next Monday to Wednesday, and we're really going to try and iron out and get some sub workflows working on Nfcor. Configuration is also quite important, and so when we went about developing Nfcor modules, we wanted to make sure that they were flexible. So what this means is basically, rather than having a module in a pipeline that has hard-coded parameters that is used by one pipeline developer and can only be used by one pipeline developer, we wanted to write and develop modules in a way where you can overwrite any non-mandatory arguments that you would pass to this tool. And so that then makes it easier for downstream users to then tweak the behavior of the pipeline based on simple configuration that they can feed in on top of the standard configuration provided by the pipeline. This makes things more flexible. It also puts less pressure on pipeline developers to create releases, which can take some time. All of this configuration is generally set in Nfcor pipelines in this modules.config file, which sits in the conf folder in the pipeline repository. And as Phil took you through, Nfcor tools, there's a bunch of commands and automation that we've added to deal with a lot of this functionality, not only with pipelines, but also with modules. And I'm going to show you that in a second. So I've collated a bunch of resources here that may be useful for you. I'm going to dump this slide deck into Slack as soon as I finish this, this presentation. All of these links work. I'm not going to be able to cover everything regarding Nfcor modules and stuff. I'll try and give you a good enough overview as to what you can get from it. But anything else, there's some mammoth talks here about contributing to Nfcor modules. Some of the principles may be outdated a little bit, but in general, in terms of testing and adding modules and stuff, the same sort of principles apply. And if you want to get in touch, we have Slack. You've obviously found Slack already. We have a modules channel there where we have a modules team and a bunch of other people in the community that are doing exactly what we are doing and everyone else is doing. So feel free to come and talk to us there. We also have a sub workflows channel as well, if you want to come and find us there as well. And yeah, thank you in advance to the Nfcor community, the Nextflow community, Biocontainers, and my awesome colleagues at Secure Labs. And so now I'm going to jump right into a demo now. For those of you that were interested in why I was chuckling earlier, it was basically because after Phil's comments about how we managed to scrape everything together last night, I was looking for the appropriate GIF, and then I managed to find this, and I was sharing it with the other guys on that are helping out during the event. Yeah, sorry, Phil. I won't do it again. Okay, so in terms of what I'm going to show you, I've attempted to write up a lot of this in this document here. It's a follow on from what Phil was showing you. And so here there's a module section right at the bottom here. And I'm going to basically be following this through and taking snippets out of here and showing you what I'm doing. And so I've got this in another screen, so I'm just going to close this for now. And I'm going to open up a Git pod environment and Nfcor tools. Okay. Cancel that, open in browser. So this should take a second or two to warm up. Right. So now I'm just going to come out of this directory to the directory above, and I'm going to create a pipeline. So let's see if we've got Nfcor installed, which we do, and this beautiful output from Rich. So now the first thing I'm going to do is create a pipeline here. And Phil kind of showed you how to do that, but it's just simply Nfcor create. I'll give it a workflow name, Nfcor training pipeline. We want to customize bits. Nope. Okay. So now we have a pipeline. I'm just going to switch to this folder as well to show you what that looks like. So I'm just going to open the folder, Nfcor demo. Okay. Console browser. And so now the top level directory here is just this repository. And so what I'm also going to do now, I might as well get the test running. I want to make sure that this pipeline is working. And so I'm just going to run a test in this particular directory to make sure that everything is working. And so this should take a second. And in the meantime, what I'll do is I'll explain briefly what the structure here looks like. So you've got a bunch of boilerplate files here that you can use for various purposes. There's a change log. There's, in terms of modules, there's three main directories. There's modules here. Modules can be separated into local and Nfcor modules. So local modules are those that typically you may want to keep close to the pipeline because they're quite niche to the way that you're writing with the pipeline and potentially not amenable to sharing, like, say, for example, the modules on Nfcor modules, which can be used in multiple pipelines. So you've got local modules there to your pipeline, and then you'll also have Nfcor modules. So these are actually installed directly from Nfcor modules on GitHub. And so all of the modules themselves are hosted on GitHub. And with the tooling that I'm going to show you, we're basically querying the GitHub API and installing these modules directly into the pipeline. And so we have one source of truth on Nfcor modules, and then these are then, via the tooling that we've got, maintained and managed within the pipeline. Then we have a sub workflows directory here. Again, we've got local. So this sub workflow may be something specific to this particular pipeline. And so we've put it in this local folder. And hopefully next week, drums please, we'll have an Nfcor folder here as well, where we can install sub workflows directly from the tooling that we've got on Nfcor. And so then, as I mentioned, that will allow you to share chunks and functionality rather than individual components. We then also have a full-fledged workflow here. So this is like an end-to-end pipeline where you will be including either modules or sub-workflows directly in this main workflow in order to run the pipeline from end to end. And you can also have multiple workflows as well, depending on how you set the pipeline up. You may, in some instances, have a workflow for Illumina analysis and another one for Nfcor. They're completely distinct, but there may be aspects of the same pipeline that allow you to share functionality between the two of those. Great. So we've got the tests working. Let's just check everything looks okay in terms of the linting. So this will go away and check that everything adheres to some standards and other things that we've set in the Nfcor tools package. And hopefully we've got all passes, which we do because we released this yesterday. And so we fixed a lot of this yesterday anyway. And so, yeah, we don't have any failures here, which is great. There are loads of warnings here for to-do strings that Phil probably alluded to in his talk, where these are just essentially guidelines for you to come in and change the pipeline template here in places that you may need to. And so we put to-do strings there just to remind you and you don't forget. And these come up in the linting. Okay, so now let's try and add some stuff to this main workflow. So here, first of all, let's copy a process in that I've put on the website there. And yeah, this is just a process that takes as input a channel with a meta map, which you'll see quite a lot on Nfcor, and I'll briefly explain that in a second, as well as path to some files. In this case, they're just FastQ files. So at the moment, I've just copied this process into the main script. It's not doing anything there. It's a bit like defining a function. In order to actually use this, you need to invoke it in the main workflow. So let's first see what the contents of this channel looks like. So here, I'm just going to put the magic resume at the end now. So it will only rerun tasks that have been set not to be cached. And so the meta map is a bit like whilst this is running, a meta map is a bit like a Python dictionary. It's something we've adopted across Nfcor, and it's become very important with the way that we are sharing modules on Nfcor, because you can imagine when you pass data around a workflow, you may want to associate that particular data with metadata, like, say, for example, in the RNA-seq pipeline, we need to pass metadata like strandedness through the entire pipeline. But that metadata will be different for a ChIP-seq pipeline where you may need antibody information, or it may be different for a variant calling pipeline where you might need patient information. And so this meta map just gives you that flexibility where you can have an arbitrary Python dictionary type structure or object that you can pass around the workflow, and you can add and change the entries in this depending on your use case. So here in this case, this meta map is just a couple of key value pairs where you have an ID, and it tells you whether this particular sample is single end or not. And so in this case, it's not single end, which is why we've got two sets of reads. Here it is single end, and so you've only got one read in this case. So if we want to share modules, we need to have a flexible way to pass this sort of metadata around different pipelines if we want to reuse them in different pipeline contexts. And that's where this meta map comes in. If you hear it in the Nfcor context, then that's exactly what it is. It's just a dictionary to pass around sample information, essentially. And so that's what that looks like. And based on what the output of this input check channel looks like, you can see that we've configured this correctly, because we've also now taken as input a meta map and some reads. So now all we need to do is invoke that echo reads process within the main workflow. So here, I'm just pasting that here. And so now what should happen is this process will take as input a channel with two elements, the meta map and the reads, and it will just echo the names of those particular read files. So there you go. It's just printed the names of the files and is working exactly as expected. Now, if you want to use a module, the problem with having the process directly in the main script here is that we can't really reuse it, but you can if you put it in a module script. So here, we can't really reuse and share it properly. And so what we can do is we can go to this local folder. This is custom module we want to add. We'll add a new file here, and we'll call it echo reads.nf. So now all we do is cut this out of the main script, paste it in here. And we need to now tell Nextflow where to find it because we've moved it out of the main script. So we paste this include statement here and rerun. So now instead of calling that script from the main script, that process from the main script, we're now calling it from a separate module. And then you can share this module and do whatever you want with it afterwards. It then becomes sort of a, as I mentioned, a unit of functionality. So there you go. It's done exactly the same thing, but now that process sits somewhere else. What you can also do is invoke the same process more than once. So now I'm using exactly the same process, but I'm calling it twice in the same workflow. And so here I'm including it as these names. And so I can come in here and just say once. And now, for those of you that are still awake, this should print the reads twice. There we go. So I guess this highlights to you how powerful it is to be able to use these modules in different contexts. This was just a simple example, but there's almost definitely more complex examples which require configuration and lots of other things that need to be taken into account, especially when you're running standard bioinformatics tools. And having modules that are shareable in this way makes it very nice in terms of the fact that someone can update the modules, or you have a central location where you can update these modules and reuse them directly within pipelines. You don't have to keep on updating the logic. You may even get others that come and contribute and update the version of the module or the way it runs, and that was breaking before, that there was a bug. And so it's advantageous not only for Nfcor modules, but also Nextflow pipelines in general, because it allows you to write structured workflows in your own setting as well. So there's a number of other really cool commands that we've got in Nfcor modules as well. So if I do Nfcor modules list local, I already showed you that there's these 3 Nfcor modules that we've installed in the pipeline. So this will go away and tell me exactly which modules I've got installed from Nfcor modules, where they were installed from. So you can even install modules from forks of your repository. We added that functionality because there are a number of members of the community that wanted to maintain their own forks of Nfcor modules and install directly from there, because they just wanted to have more control over what they were doing. That's completely fine. And so you can also install directly from your own fork as well. What we're tracking here for version control for these modules is the Git hash that this module was installed from. And so that in fact is tracked within this modules.json file. And much like the parameter schema that Phil showed you earlier, you shouldn't have to edit this file. This file is simply here as a record to show where you've installed all of these modules from and at which version you've installed them. Nfcor tools is what uses this to update modules, to install modules and remove modules. It will directly interact and change this JSON file as and when it needs to do that. You shouldn't need to update this manually. So that's the modules and where they've come from. So that's the modules list local command. Let's now try and update all of the modules in the pipeline, which is another command. So this is really nice. Back way when I was sort of developing prototypes for DSL2 with RNA-seq and stuff, I had to manually update all of these modules by hand. And it was painful. And this particular command was a revelation, because when you have 20 or 30 modules and you want to update them all at once, this sort of does exactly that. And so you can update them. You can view the diffs as well between what is in your local repository compared to the remote to see whether you want to accept the changes, and also just to give you an idea as to what has changed. Or you can just brute force update everything. And so here, it's just telling us that everything is up to date, but we know that already because we just released Nfcor tools yesterday and everything had to have been up to date at that point. But for more of a realistic example, whenever we release Nfcor tools, every pipeline gets an automated sync pull request like this, which means that you need to merge in the template updates. Anything that's changed in Nfcor tools in the pipeline template then needs to be merged in to your pipeline as well, and in an automated way. It's really nice because it means we can send this out to 60 or 70 pipelines to make sure that they're all up to date. But when we also released yesterday, we restructured the way that we were using modules. And so that was a big change on the modules repository, and the way that the modules are also installed in the pipeline itself as well. And so I literally just had to run one command to update all of the modules that are currently in the pipeline. And the modules JSON itself was updated automatically. You can see here, I didn't have to do anything. So when you start looking at production workflows and doing things at scale, it really makes sense to have some sort of automation in place to do this type of stuff. Okay, so that's the update command. You can even list modules that you have in the remote repository. So in this case, it's Nfcor modules, what sits there in GitHub. This may not be very useful because there's 600 modules there that you don't want to be scrolling through, but we do have on the website, if you go to the website and just /modules, you can search for all of this directly on the website here. It will take you to the correct modules, and you could search based on tags and all sorts of other information as well. So let's try and install a module now. We have to bear in mind that we're still working in the pipeline context here. So let's try and install a module in the pipeline. Oops. Nfcor modules install. Let's install FastP, which is a very popular trimmer in the genomic space for adapters and all sorts of other stuff. And so now what we've done, again, with a very simple command, is we've installed this FastP module. This module sits on GitHub in the Nfcor modules repository. Nfcor tools will query the GitHub API, fetch the module, install the pipeline, install the module wherever it's supposed to be installed within the pipeline. And so here you can now see that we've got this FastP module that's been installed in the pipeline. This has probably gone through various iterations of updates from various members in the community, bug fixes, adding optional outputs, and really extending the functionality of this, even just this one module. There's a meta YAML associated with it, which I'll show you later when you create modules, that you fill in to add information about this particular module, the documentation, licensing, input and output information, and author contributions as well. So now let's try and wire this module into our pipeline. So here you can see it's got exactly the same structure that we're using for the echo reads process, where you've just got a meta map and some reads. And so what I'm going to do is try and get FastP running here with exactly the same method I did for echo read. So what Nfcor tool also does, it prints a nice include statement that you can copy directly from the terminal to include this module in your pipeline. But we still need to invoke it within the pipeline here as well. And so what we'll do is copy that from the website and put this in. And so here you can see we're just passing exactly the same channels, which again is another strength of DSL2, because you can reuse these. These channels aren't exhausted, which they were with DSL1. And so in the FastP module, there's a couple of Boolean inputs as channels here, which determine whether you want to save trim FastQ files or merged ones, but we're not interested in that at the moment, so I'll just set those to false. And then we can try and just run the pipeline to see if it works. You can also get module information directly from the command line. So I'm just going to come out of here for a second in the new terminal. There's a command called Nfcor modules info, and that will tell you pretty much all of the information that's in that meta YAML. It will go away, parse it, and tell you more information about the inputs, outputs, and even how you can install this particular module in your pipeline. So there we go. FastP is now running. It's been wired into the pipeline, and we're still echoing those other reads as well. Right. Say, for example, you want to make a change to this module, and you don't necessarily want to contribute this back to Nfcor modules. You want to use the bulk of the functionality that comes with this module, but you don't want to create a pull request and update Nfcor modules. We're obviously always very welcoming of updating these modules if they're of general benefit, but it may turn out that you want to do something custom to this module. And so here, let's just add in a random echo to say that these are my changes and save it. Now let's try and run Nfcor modules lint FastP. And what should happen, and what does happen, is that the linting fails now, because what Nfcor tools has done is detected that you have made a change in this module that isn't the same as what's in the remote. Now, given the fact that we're doing versioning and we're tracking the versions in this modules.json, it's very important that whenever you install a module, it's installed at a particular version and you're able to track any changes that happen. Otherwise, it breaks that whole reproducibility. There's no point in you using that versioning. And so the main reason behind doing that, obviously, is because you need to know what version of a module that you've installed and be able to track that. Especially, say, for example, when you want to update the module, you need to know exactly what what hash you have and where you want to update it to. So there's a really cool tool that that we've also got in this package that allows you to patch this particular module. So now you can see the linting is failing because the local module that you've now changed doesn't match what's on GitHub. So what you can do is modules patch fastp. And what that will do is it will create a diff between what's on the remote and what you have locally. And it dumps this fastp.diff file with the module right next to it here to identify what the diff is. And what also happens is in the modules.json, a patch line is added here that tracks this diff. And so now when the module gets updated, this will automatically be applied for you. If we try and rerun the linting, so now let's try and rerun the linting for all modules, in fact, also, which is quite nice. Then we don't have any lint failures anymore. And that's because we've accounted for the fact that we've changed this module locally. Okay, so that's patching modules, which again is very powerful if you want to use a module in your own specific way. And a lot of people have actually started using that particular command, which is awesome. So now let's try and create a module. Nfcor modules create. Sorry, I forgot to increase the sizes. I just realized now looking at it. Oops, don't want to get smaller. So Nfcor modules create, and you have to remember that we're now running this command in the pipeline context. And the way that Nfcor tools knows this is that we have this nf.nfcor YAML file, hidden file, that tells it what type of repository we're running this particular command in. And so the fact that we're running this in the pipeline context, what we can do is we can create a module here, give it a name. Do you want to use a different Bioconda package name? No. So what this is doing is, if the first part of the name of this tool matches something that's on Bioconda, when Nfcor tools creates this package, it will automatically populate the container fields for you, because it will go away. It'll say, okay, you're using a module called samtools/index. It will go away, look for samtools on biocontainers, and it will then populate the container definitions automatically for you within the module. The API was broken yesterday, so I'm not going to risk it today on a demo. But typically that's what it will do. It will go away. So you don't have to go away and look for any containers anyway. It will go and automatically populate the containers there for you. So for now, I'm just going to select no. And I'm going to give myself an anonymous name. I'm going to say that I want to, by default, give this process a label, or this module a label of process single. And the way that where this comes in is that every Nfcor pipeline has a base config file. And in this file, we set some sensible defaults or groups for groups of resources. And so for here, process single is just a single CPU and a bit of memory and time. And then process low is a bit higher, process medium is even higher, process high is double of process medium, and then you have long and so on. Where this is nice is that you can then create modules with standard groups of labels. And so if we look at the fastp module, you'll see that it's using process medium, and that's potentially because with fastp it can be multi-threaded, and so you give it a decent amount of multi-threading for it to work in that context. Similarly, you may have another one that only requires a single CPU, and so there you would just give it label process single. And so this allows us to standardize the labels that we're using on Nfcor modules as well. Why is my window too small? There we go. Okay. And then this asks whether you want to add the meta map information to this particular module. Not all modules will require passing around a meta map. So some modules won't be dependent on sample information. So you don't need to pass that meta map as input to that particular module. And in those cases, you can just select yes or no. So here I'm just going to select yes. And what you notice is that Nfcor Tools has now created this module directly in my local folder for me to then go and finesse in my own time. So here I've got the demo modules.nf. If we look at this particular module, you see there's loads of to-do statements that are mainly there as a guide to help you figure out whether you've done everything or updated the module in the right places. A lot of it can potentially be deleted when you get more confident with the whole process. And so it's a bit like the to-do statements that we have in the pipeline template. They're there so people don't come in and look at this and just get confused by what's here, essentially. And so, yeah, that's what this looks like. And the reason that when you run Nfcor modules create in the pipeline context, the reason it's created a local module is because this module is something potentially specific to your pipeline itself. And it allows you to automate the creation of that directly in the pipeline. You can then amend and change the functionality and so on, but still using the same structure that we're using on Nfcor modules. So what I'm going to do now is show you how this looks different if I were to run exactly the same command in a clone of the Nfcor modules repository. So if I come out of the pipeline repository now and I clone the Nfcor modules repository from GitHub. And go into that directory. And what I might do actually is change the folder. So we are in there. Right, here we go. Top level is, I don't know why it does that 1R thing. Yeah, so now we're in the top level folder of Nfcor modules. Again, we've got the .nfcor YAML file that tells Nfcor tools that now instead of a pipeline repository, we're running in a modules repository. And so the Nfcor tools commands will have to be adjusted based on the context that we're running this particular. I mean, before we had a bunch of auto detection for this to look for particular scripts and stuff, which is a bit fragile. And so in this case, what we decided to do was just to have something a bit more explicit that we can say, yes, this is a modules repository, or this is a pipeline repository. And so now if we check out a branch, because we don't want to edit stuff on master, we see all of the same things. And now let's run Nfcor modules create. So if you remember in the pipeline context, we only created one local module within the pipeline itself. When you run it on Nfcor modules, so the prompts are the same. But now we've created more files. And the reason that is that typically whenever someone comes in and clones Nfcor modules and wants to work with that, or even a fork of their own, they typically want to contribute these modules back to some sort of source repository and add tests and do that type of stuff. And so here, we've got two files that have been added in this modules folder, which we can have a look at here. And so this is the main script. It looks exactly the same as when we added it to the pipeline. We have a template, a modules template in Nfcor tools that we use to install this directly into the pipeline. We have a meta YAML here that you need to fill out with the information about the module. So a number of downstream tools like Nfcor modules info, for example, parse this file and dump that to the CLI. This sort of information is also used on the website for searching and that type of stuff with the tags and keywords that you use. And so this is quite a valuable pipeline. So anyone that is contributing to Nfcor modules has to fill out a certain bit of information about the module as well, to just so that it makes it easier overall for everyone and standardize things in general. And so, yeah, once you're comfortable, again, you'd go about developing this pipeline. But we also have a number of files that we've created in this tests directory. And so let's have a look at that. Tests, modules, demo. So we've created these three files here. This is a template script that you would use to test this particular module. Now, this is very important because any module that gets added to Nfcor modules has to have unit tests. We need to make sure it's working. There's, as I showed you, there's 150 different contributors. If someone comes in and updates a module, we need to make sure that it's always working. So whenever you create a pull request to Nfcor modules, there's a number of CI tests that get triggered for all of the main containerization. So for Docker, Singularity, and Conda. this module is running all of those different settings to make sure that it's working before that pull request is merged. There's also some linting that goes on the pull request to make sure that there's certain things like prettier and black that are happy before you merge this module in. And so that just allows us to keep a really nice tidy code base as well in general. And so when you're happy, you can add tests for this particular module. Here, I'm just linking in some test files. We've created loads of files. Got a bit of time, so maybe I'll show you. We've created loads of files on this Nfcor test datasets repository here, where we've collated and tried to standardize the way we organize this data as well. So here we've got a genomics. The majority of the modules on Nfcor modules will be using test data from SARS-CoV-2 because we've had heaps of that around recently, as I'm sure some of you may have been affected by. And so here we've got some genome files. We've got Illumina, SARS-CoV-2 data, Nanopore, and also metagenomic data. So you'll have various types of different files. And over time, we've built up this resource, which is a really valuable resource for minimal test data, which in itself is really valuable. It's very hard to generate minimal test data like this that works or you can use for testing. And in fact, we were at some point talking to other communities like the SnakeMate community and potentially Galaxy also about sharing this. So maybe something for the future. And so what this module is doing is just running a simple workflow. It's running this, it's importing this demo module, and then it's running that demo module with the test data that we provide it. This Nextflow config file is just a simple file here. It's mainly there to get a sensible publishing directory out when you run this module. You can also update and amend this Nextflow config file if you need to use, say, process selectors to have specific functionality when you're testing this module for different outputs or different arguments and that sort of stuff. You can customize this as well. I won't go into much detail there, but it's possible. And one of the key files, I think, when you want to add a module is this test.yaml. Now, for all of the unit testing we do, we use this tool called PyTest Workflow. It's a Python tool that allows us to use tags like this, like demo or demo module, and also the command that you want to run. So in this case, it's just saying, I want to run tests, modules, Nfcor demo, the demo module. I want to use this entry point. You can have various different entry points. So you can even have, at this moment, it's just one entry point for test demo module there. But you can have, you can have another entry point for test demo module under 2. And then in that case, you would just append an additional section here for that particular entry point. And for each entry point, you may have different output files. And those output files may look different depending on how you've run that module. So if we just have one entry point, for argument's sake, say it generates a test BAM file, we now can look at doing MD5 sum checks on this BAM file to make sure it's exactly the same when you update it over time. And we can also do a bunch of other checks like looking for file contents and also making sure that files are present in a directory and so on. And so this is really powerful for unit testing. PyTest Workflow is really powerful. There is also another tool that is becoming quite notorious in the Nextflow Groovy type space called NFTest. And in the future, potentially, we may be looking at assessing that. It's more native to Nextflow and Groovy, and it looks promising in terms of the functionality it can offer. So we'll look into that as well. And so that's it. When you add a module in Nfcor modules, there's 5 files. Basically, you have to play around with to get the test passing for your specific context. You give the module a name. You put the appropriate input and output channels in the script section as you would any process. And then you add the appropriate tests based on the test data that you use. In the resources that I sent you, there's some really extensive talks about this and how to go about that entire process. And maybe you can follow up on that later on down the line. But just to show you how easy it is to run the tests in a very portable way. Say, for example, we want to run the tests for SAM tools index. and we want to make sure that it's running. So locally, all you really have to do, I mean, in my case, I just set a temp there to my home directory. I say I want to use Docker. I'm using PyTest. These are standard PyTest options. And the only thing really that you need to change is this module name here. So I want to test that SAMTools index is working. And what will happen in the background is that PyTest will go away based on the tags that I've specified here. It will go and find the SAMTools index module, which is SAMTools index, and it will run through all of these different workflows that are specified here and make sure that the files that are generated by all of these different workflows match what has been specified here. So you can see it's just going through all of these different workflows. It will check the MD5 sums of the output files and eventually come back with an overall result, whether this is passed or failed. There we go. So everything's passed. This module's working. If I change it, I rerun the tests. These tests will also be run on the pull request when you create them to Nfcor modules. If I want to run it for a different module, I just change the tag. And so this makes it very easy for everyone in general to test when they're contributing to modules. We wanted something with a low barrier of entry that anyone could use, and this kind of fits the bill. A lot of the automation we have when we use Nfcor modules creates all of the necessary files for you in all of the correct places. All you really have to do is then substitute whatever you need to customize and add your module there with hopefully minimal overhead rather than doing everything from scratch. Which again goes back to how automation is key for a lot of this and very important. So hopefully that gives you an idea as to how a good overview, in fact, of how we're using Nfcor modules on Nfcor to standardize a lot of the things that we're doing with it, not only with Nfcor pipelines, but also with Nextflow in general as well. And yes, thank you for tuning in and giving me your undivided attention. I'm sure you didn't look away throughout this thrilling talk. So I look forward to meeting some of you guys in person next week, and also interacting with you in the Nfcor community as well. And if there's any questions that you guys have, then feel free to ask us. We're very willing to help. Thank you. I think we've got a break now for 10 minutes. So we're going to come back at 8 o'clock, I believe, for Evan's talk in a while. So there's a break now. Thanks again. Bye-bye.
Okay, welcome back, everybody. So as a quick reminder, so my name is Evan. I'm the CEO, co-founder of Secure Labs, and I'm going to be doing the final session today. This is going to be focused on Tower and Nfcor. Just a quick reminder of where you can find this information. So we're looking here at the training material. We're going to be up to section 12, and there's a lot of stuff which is actually not covered directly in here, but going to be a bit more of a demo and just give you a kind of a background as well on Tower itself, and hopefully it makes a little more sense now we've seen the development of the Nextflow pipelines and the like, and we can see a little bit more into that. So background on Tower itself. After developing Nextflow for several years, we realized that there was a kind of a key problem and a key kind of problem that we're trying to solve here, which is around the Nextflow is fantastic if you want to use it by yourself or run a single application, maybe from the command line, etc. But when you want to be able to take your pipelines, maybe scale them out across your team or share them, make them available to other users, call them as a service, have a history of all of your data and sort of have a history of all your execution, it becomes very difficult to do that from a command line tool. And Tower is really the kind of solution to be able to do that. So what I'm going to do first is just kind of show you the basics of it. You can find all of this at tower.nf. So I just log out here. So if you go to either search for Nextflow Tower or tower.nf, you'll find this. And the way Tower is set up, it's supposed to be kind of flexible, a little bit like Nextflow in the sense that you can install it in any location. But this is the hosted version here. And when you run the pipelines, when you essentially do the execution from within Tower, that is separate from where Tower is installed. So it's got this full portability like Nextflow in the sense that you can run things in different locations here. This is the hosted version, or we call Tower Cloud. You can come in and try this if you sign in here. You can sign in with your GitHub credentials or your Google credentials. And when you sign in, the first thing you'll see here is this a collection of pipelines. When we started this, the first thing that we were trying to do was obviously this monitoring and also the kind of having the history and basically a database of your analysis. I'll kind of go through the evolution here of how this works. When we started, we wanted to be able to essentially take things from the command line and have a way to monitor them. So what we can do here, and if you follow the training script here, is we can simply take an Nextflow pipeline that we've been running before, like script number 7, and all we need to do is place on the end of it with Tower. And by doing this, then when we run this pipeline, we can then monitor that inside the user interface here. So you can see, for example, I'm just going to go to my personal workspace. The way this is set up is that you've got this concept of organizations and /workspaces here. You can see this communities I showcase. You also have your own personal one when you sign into here. So if you want to follow along here, you can come and sign in. You'll have a personal workspace. And the way that you can do this with Tower in terms of using the with Nextflow option from the command line is you put a token and you essentially use that token to link it. I'm just going to go here and launch that pipeline. So when I write script 7 with Tower, I can then go to the runs page here. And the run, as it comes, as it's basically going to start up here, it's going to come here. It's going to be visible for me to see. I can monitor the status of it from here. But I can also jump into it and see some information. So here you can see script number 7. It started running here, and it's the exact same thing. You can see here. I can jump in and monitor that live. Here it's very minimal in the sense that this pipeline just runs for a few seconds, but I can follow the status of those tasks. I've got a history of the command line, the parameters, configuration, etc. Here you can see some basic information that's available to us. You can follow the status of those tasks, of the processes. We've got some basic aggregate statistics for time, CPU, memory, etc. And what's really nice is we've got a task table here, so we can quickly go through and find a particular task. Maybe we wanted to find the salmon sample where we ran, for example, on lung. We can select this here and find this here and do this. I point out when I'm running this is from the original Git pod that we were using, the one that you can find in the training notes here. To do that. If you want to try this now with your own Git pod environment, the only thing you need to do here is create a token, which you can just do once inside of Tower, and then you take that token and you export it to your environment here. And that's good to go. Then you can use with Tower. Just to show you from Tower's perspective here, you can go into the user icon here. and you can look for your tokens, and you can create one there and make that available from there. So that's the kind of I guess the basic point that we started with regards to Tower in terms of its monitoring. Over time, though, it became kind of clear that there was a sort of much more need that if you wanted to not only monitor, but you also wanted to launch those pipelines with Tower, you're in a situation where you're not so dependent on this, keeping this environment open. So here I'm running from a Git pod environment, which in essence could be pulled away, but I could also be running from my laptop, in which case I would need to keep this open. And there's a whole bunch of things that has to take place here. So that Nextflow is sending the data back to Tower, but we're kind of essentially responsible for Nextflow running here. What we could do and what we wanted to kind of think about was actually removing this itself so that you could think about Nextflow, basically calling Nextflow as a service. And the way that we can do that is to actually launch the pipeline itself from within Tower. So I'm going to jump into here to a different workspace here. Here I can essentially build the Nextflow command line to a certain extent. I can kind of launch a pipeline and go through from that stage. So I'm going to do a quick launch here. Here, I want to point out that I'm showing you all of this from the user interface, but the exact same thing can be done from API and also from the Tower CLI, which I'll show you in a moment. Here you can see that I'm defining essentially the pipeline I wish to launch. I can put the name here, so I can provide whatever name I wish. I can add some labels. So maybe I want to associate this with a particular project and some RNA-seq data that I want to run here. Then the next thing that we can choose is a compute environment. I will explain this later on, but it's essentially a way that you decide both where Nextflow runs and also where the compute is, the compute of the tasks are going there. And here I can put a Git repository. So I want to continue the example that we had. Let's just say Nextflow RNA-seq, and I want to find the NF example here. Here you just copy the Git repository. This could be public, private, hosted, whatever you've got there. And then you can paste it into here, and you'll notice that this blue little circle on the right-hand side, this is it going to GitHub. It's going to look up the branches, the commits, the tags, etc. Make all that information available. And from there, we can see the particular revisions that we've got. So we can say, I want to run a particular version. All of that corresponds to the releases that we have here or the branches that are available here. So again, providing us kind of a UI into being able to do that. Let's say that we wanted to run a particular version 2.1, and you'll notice here that now we have a working directory. What this means is this is essentially the location of our work directory itself, where the intermediate files will go. And this compute environment, which I've set up here, is in EUS3, which is in Paris. And that means I've created a bucket here in Paris for me to do that. The final thing that we can see here with regards to setting up the pipeline is these config profiles. And if you remember from yesterday, the Nextflow configuration, in the config, you can create a concept of profiles, which is a way to group together config. And here, this is basically going to pass the Nextflow config file. So if we look in the Nextflow config file of this repository, this is essentially passed for us. So we know which profiles are available to us for that repository. So we've got Docker, Slurm, Batch, etc. And then when I go to launch the pipeline, it's going to show me all of those, and I can choose what I need. Important to point out that given the fact we're running here in AWS Batch and the like, we don't need to tell Nextflow here a particular profile. The profile, essentially the information for the configuration of that execution, it's going to be handled by Tower itself. Okay, so in the first part, then we've got this information that we wish to put in here. So we've got our essentially what pipeline we're going to run, where we're going to run it, the basic things, and we can simply select kind of launch here. What's taking place in that case then is the pipeline itself then, essentially the Nextflow run command, essentially this command here is being submitted, in this case, to AWS Batch. This is a slightly different approach from before, where here I'm running Nextflow in this machine. In this case, I'm submitting the Nextflow run job to some sort of compute. It can be a cluster, it can be cloud, it can be Kubernetes, it can be sort of essentially anywhere. But from there, the Nextflow job, the Nextflow run essentially command is going to be submitted to the individual compute as well. So let's have a look a little bit what that looks like in practice. I've got this community showcase here. You can go into here and start trying things out. I would recommend, if you want to log into here to try and get a feeling for this, is just to run some pipelines. All of those are available there. There's some free compute to go give things a go. And important to note out, this is just essentially running into compute, which we're providing here. You can connect in your own one, and there's kind of no cost associated with that. If I select here this pipeline that I triggered a little while ago, you can see that here we're running now the Nfcor RNA-seq pipeline. You can see we've got the version that we're running here. We've got parameters, configuration, data sets. I'll mention in a moment. This is a way of linking in essential specific, particularly sample sheets that we're going to be using for input. We've got an execution log, and we've got some reports, which I'll mention in a moment. Scrolling down, you can see we can monitor the status of those tasks. So you see I'm on the final task here. I think this is probably multi-QC, which is running. I can follow the status of those. I can even see inside of the process block. So you can see there's quite a lot of processes in the multi-QC, in the RNA-seq pipeline here. We've got aggregate statistics on CPU time, memory, read, write, and cost as well. So there's actually a database on the back end, which is looking at all of the costs associated with each cloud provider in each region and each instance type, so that we can basically say, okay, this task itself is using half that virtual machine, and that virtual machine costs X dollars per hour, and or X cents per hour, and we can calculate all of that up. There's also information on cores, so we can see we're using 2 cores at the moment out of a total of 48, or the maximum we've been using is 48. We're using 1 task, and the maximum we're using is 24, and we can see some memory efficiency and CPU efficiency. When you launch in Tower, you get a lot more information because there's more information that we can send back. What we're able to do is, for example, jump into the task table and say, show me wild type replicate 2 sample, and I want to find out what happens when we run star align. I can jump into that task. So as well as the information that we get from the script section, which is essentially the script section of the Nextflow pipeline evaluated here, we can jump into the execution log, and we can see the actual log for that task. And this information is typically quite difficult to get because it would be essentially a containerized run of that task, and you have to go find it, maybe in some bucket. Difficult to get at. Here we can also access those logs themselves. The task, remember, is a containerized task. So each of these tasks, in this case, it's 200, but it could be 10,000, are running in themselves in a container. So this task ran inside the star container. It's star align after all. It ran on this queue. It requested 2 CPUs, 6 gigabytes of memory, and 3 hours onto the compute. We were using the AWS batch executor here. It got placed on an R4 large machine type in EU West 1 using Spot, and therefore we get some kind of estimated cost of that in itself. We can then compare the resources that we requested with the resources that we actually used. And from that, we can start to optimize that. So when a pipeline is complete, we can kind of visualize that over the pipeline. And let's go up to the top here. You can see this one's not quite, it just finished for us now. So that's fantastic timing. So when a pipeline is complete here, what we can do is we can start to see a little bit more information, for example, on the reports. This is a way to define the output of a pipeline that you may wish to look at. For example, HTML report. We can see here the multi-QC, which is coming from many of the pipelines which we can create here. You can see this information and access that. We can also generate information from PDFs or images, structured data as well. Here's a quick image of it's coming from comparing our samples across the types here. We've got the salmon sample, for example. Here's some structured data that we have for all of this. And this makes it very easy to kind of jump into those things. I want to draw your attention to this section here on the path here. And Tower is not like a SaaS tool here where you're kind of running your things, you're uploading your data into the environment, and then you're running. It's much more of like a transparent view on your own compute. So even if you're using the cloud version of Tower, this is still like your path. This is your bucket. The compute is taking place in your environment, and then you're able to kind of provide this view into that information. And that's a very important distinction here in terms of the way this runs, and it should become a lot clearer when we look at the compute environment itself. Also, otherwise, we can consider that if we also want to look at the resources that we've used as part of this execution, you can see that we've got CPU, for example, across those processes, as well as memory, and we can start to optimize that now based on the previous ones. And I can show you some of that work in a moment as well. So that was a kind of, let's say, a basic launch that we had done where we created the pipeline itself, where maybe we were adding that. What happens if you want to do, say, more complex pipelines, or you want to make them available for people? Maybe it's a pipeline that you're running very often, you're running it in production, and you want to make that available for people. Well, before, you would have seen that there was, and as part of the section there on Nfcor, they were looking at the Nextflow schema. And the Nextflow schema, when you place that inside of your repository, you're essentially able to get a UI for free in part of Tower. So for example, when I go into, if I want to go launch a pipeline here, say the RNA-seq pipeline here, this whole form, the fact that I provided a schema, or the fact there is a schema itself is part of the repository, means that I get this whole UI for free. So here you can see that there's input, there's outdoor, etc. And this icon, this text, this help message, etc., can all be defined as part of that schema. There's also a key part of that when you want to define, for example, if you specify it's a particular MIME type and the data entry point, I can say here, for example, RNA-seq, I can find that particular data set. And from that data set here, I can simply launch that pipeline. It makes it very easy to manage the data here and kick that off and launch. Obviously, I've got Booleans, I've got other sort of points here. Another thing I wanted to point out with regards to that data set. So here you can see inside of the showcase, we've got some sample data sets, mostly for just test data. The structure of these is typically around the concept of sample sheets, where you've got CSV, TSV, text-like files, and those files have typically got some kind of columns to them, which we can reference. Here you can see we've got a sample ID in the first column. We've got the locations of those files. And this could really be anything. Nextflow can read from many, many different file types itself, so you don't have any issue with that. And the credentials are essentially part of the compute environment. So accessing these things, in this case, it's public, but it could be private. And you've got this concept of the metadata itself. So this could be essentially a way of telling how to process this sample sheet. You can add these via API, but one thing that we're in the kind of direction that we're thinking about taking this in is the kind of concept, so expanding a little bit of the work that Phil's previously done with the SRA Explorer here, where you could, for example, search, in this case, a public data set. So I could search, for example, human liver microRNA in the SRA. I could find the samples that are maybe interesting to me. Maybe I wanted to compare these particular samples as well as these ones, etc. I can then create a sample sheet. I can essentially create these data sets themselves. I can download the metadata for these, in this case, in a TSV file, and then I can go to Tower itself and then upload them. So by uploading, either dragging or dropping from API, you can see if we set the first row as a header here, now I've got some sample IDs. I've got some information. I know how these were sequenced, so I can maybe process them differently, etc. And I've also got the locations of either an SRA or, in this case, an FTP. Nextflow can handle all of that, and that could then be the entry point for my pipeline, essentially my sample sheet. And we're kind of thinking, obviously, still expanding out this, so beyond SRA and public data sets as well. So a little bit of a side and kind of a pointer to where we're going for the future with that. The other thing I mentioned before is that when you kind of get this UI for free, we also saw the fact that we could create these reports. And when you're defining your pipeline here, as part of that, you can specify, so I'm just going to show you an example of what those reports are going to be. So if I go into here, there's a concept of one of the more advanced options here is what we call a Tower configuration file. And inside that Tower configuration file, we can basically say exactly what we want to report on. So we can say, okay, we want some reports. We want one that's a multi-QC report, and we can give it this name. We want to find, for example, the DSEC2 plots, which we want to call DSEC2, of course, as well as like any files that we want. So by specifying this, that makes them available for people when they see them, when they're running from there as well. So that kind of provides the kind of the basics of that. So we've now kind of seen how you want to add your own pipeline, how you can make those available when you're going to launch them, kind of what happens a little bit. But the real magic of the system is the concept of how it can connect into any compute. And to reiterate that, I'm going to jump into the other workspace that I was in before here, where I've got a few more compute environments set up. And I'm going to set up here, I'm going to say, I want to launch a pipeline. Let's just say that we want to launch this pipeline here, and I'm going to run ATAC-seek here. And I'm going to run a particular version of it. Let's say 1.2.2. And in this case here, I'm running an EUS3. So this is in Paris. So I've got my Paris bucket, etc., all the same as before. But now maybe imagine that my data is somewhere else. And maybe my data is in a different AWS account, or maybe it's in a different region. Maybe it's in a different cloud provider. I can simply switch this out and essentially say, I don't want to run on AWS now. Now, actually, I want to run in Azure on EastUS. Switching this out, you can see that everything can stay the same. Actually run the same Nextflow. What happens here is that we end up with the working directory will be different. And we could now reference, for example, the input files could be in this location here. Or we could do the same thing and run it in Google Life Sciences, or the same thing with Slurm, etc. And each time we're essentially connecting in, we're essentially submitting the Nextflow job into that environment, and all of the things that kind of come along with that. That is driven from this concept of computer environments, and these computer environments can be set up. So here you can see the examples of the one I've set up for Slurm or Azure or AWS, Google Life Sciences as well. And you can create any of these here. So by creating a computer environment, I'm going to show you one for the cloud providers, I'm going to show you one for also kind of a setup here for some of the other ones that we have. Here you can see there's batch, Azure batch, sorry, Amazon batch, Azure batch. This is actually just very recent, is the Google Cloud batch. So that's coming out of beta soon. And then there is the schedulers here in Kubernetes. If we select any of these, so if we can select Amazon batch, you can see the basic setup for this is we've got the setup for the credentials. From that, it's going to basically use the API and determine what we need. So I'm going to create a compute environment now in EUS1. It's going to show me my work directories associated with those credentials. Let's say I'm going to choose this one here, and ideally, I would always select a bucket which is in the same region. And I would also, if you're going to set this up, is set up a bucket, which basically a lifecycle policy. So this is typically temporary files, maybe cached files for 1 day, 1 week, maybe 1 month. And at the end of that, you just have a policy, which is kind of deleting all of that stuff as it goes. With regards to batch now, when I can set this up, I've got a couple of options. I've got this forge mode, which is going to create all of the resources for me. So I'm going to say I want 200 CPUs max in my queue, or you can do 1,000, whatever you want here. And then we've got a couple of options, EBS auto scaling, fusion mounts, etc. And finally, we can come to choose sort of information around how we want to do this. So we can have, for example, EFS, FSX. We've also got something here new, which is a resource labels. This is a way to add essentially a resource tag into the compute environment. So this will then be propagated through to the AWS resources. And you can start to look at some of the cost explorer, for example, and know the exact cost that you have associated with this as well. So that's the kind of basic cloud setup here. You can go pretty deep into that as well. Typically, it just needs to be set up once. There's a lot of documentation for how to do that. It's very similar for the other platforms here. There are actually maybe even slightly less options to do. So Azure Batch is pretty simple as well. Here, you just choose now the VM types, the VM counts, etc. With regards to Google Cloud Batch, it's even more simple. You choose a location, a working directory here, and you've got a couple of options for this, but it's pretty simple in terms of its setup as well. Thinking about now the schedulers, so this is typically people who've got an on-prem Slurm cluster or Grid Engine cluster or LSF cluster. In this case, you've got two options, but Tower can be running, in this case, running in the cloud, and we can connect it into that cluster, and you can either use SSH to connect in that way, or you can use what's called a Tower agent, which is just a small piece of software which runs on your cluster and connects back out to Tower itself. Either way, you've got a couple of options you set up, choose the working directory, the launch directory, and a couple of settings with regards to who you are on that cluster when you're running it, which queue you wish to use. So this is typically like a Slurm queue you're going to run the Nextflow job on, and a compute queue. And that kind of makes that available as well. All in all, this is to say that you can create these computer environments when you go to run the pipeline then I can simply go run the pipeline, launch that pipeline, and choose those computer environments as they're available to me as well. A lot of the stuff and a lot of the kind of setup here is, particularly focused at teams who want to collaborate, or if you wish to kind of do this across your organization. All of that can be done from the participation settings here. So you can see here that we've got Abhinav, who's an owner, but I could make him an admin, essentially full rights. And a maintainer is someone who's typically adding pipelines or modifying those pipelines, but not the computer environments. A launcher is simply launching the pipelines which are available there, and the viewer is kind of self-explanatory itself. And inside of the organization, so you've got a concept of organization, very similar to GitHub here, or kind of Git systems. And then inside of that, you can go into the workspace, and it's the workspace where the kind of boundary, the security boundary is defined. So each workspace has its own computer environments. It's got its own participants. It's got its own credentials. So you can create as many workspaces as you want. Inside of those orgs here, you can see that we can add credentials for that workspace, including cloud provider credentials, Kubernetes, Bitbucket, Code Commit, GitHub, GitLab, etc., container registries, and connect all of that in. And then from there, that makes it, that's kind of more on the config setup. We've got secret management as well. Secret management is typically things that you're going to have like inside of your pipeline code. So maybe you need, for example, an API token, which you're going to be using as like one of the tasks. Maybe you've got something like a license key for some of the software that you use that can be sitting as a secret, and then you never have to actually put the secret in the code itself, and they're not stored in the logs. Other than that, the other kind of key thing around all of this is automation. And we have a lot of people who want to run thousands or tens of thousands of Nextflow pipelines over a given period of time. And a lot of that can be driven from kind of API or from automation, or a typical use case is triggering a pipeline based off of some data coming off a sequencer or entering some state. And from that, we've got a couple of options for doing so. We've got actions. This is here, you can trigger the execution of a pipeline based on a commit. So if I have this webhook here, is basically, if I commit to this GitHub repository, it's going to fire off the execution of the pipeline based on these settings. This is kind of more of a CI/CD like setup. So something for if you want to do like a full run of your pipeline when you're testing it, going to production. The other key one here is a custom endpoint, so a hook, which can essentially define an endpoint itself, which you can then call from outside. So I can hit this endpoint here with my token, the same token I mentioned at the beginning, and that will trigger off the execution of the pipeline with these parameters here. And this can be really important if you want to link Tower into other services, if you want to make it kind of available there as well. Other things here, this is kind of like an easy easy access to the full API. So Tower has got a full API, which is available here. If you go into the docs, you can find that. So I'm just going to go into the docs and look up a section here and on the API, and then look at these endpoints. And these endpoints here, you can see the full API in itself. Here you've got things, credentials, everything I've shown you, setup of the organizations, setup of the users, etc. If you are running Tower, and particularly you've got a group of people, maybe in your lab, maybe in your organization, maybe in your university, you can come along here and you can set up your organization, therefore kind of making that available, and then you can add people in and essentially end up working kind of collaboratively together on that as well. Another option here is the Nextflow Tower CLI. And this is a command line tool, which is for interacting with Tower itself. So instead of doing Nextflow launch, instead of doing Nextflow run, where you're essentially running, where you're running the command, you can use Tower launch. And then in that case, essentially you're offloading the management of the Nextflow run to Tower. Tower will take care of it. You can go monitor it. You can get all the information, and you can interact with Tower from that. So you can see the pipelines, you can see actions. And I think one of the really key things here is more around doing infrastructure as code like setup. So you can import and export pipelines from the CLI, essentially they're defined as JSON. So you can just keep those files in the Git repository. And that's exactly what that's kind of exactly what we're doing here. So inside of the community showcase, all of these pipelines here are essentially defined in a Git repository. And when we make changes to them, we can import and export. It means that we can define this whole environment in a kind of open way and sort of easy to do as well. So I think my time up is just up on that. If you want to try this out, so the kind of the model for this is you can go try this out, give this a go on Tower Cloud. This is available there. We also have commercial deployments of this. So if you're an organization who wants to install this in your own cloud, etc., you can get in contact with us at Sakura, and we can help you out in doing that. There's also a community channel for this over in the Nextflow Slack under hashtag Tower Help. You'll find that over there. We'll put a link into the Slack channel there. Otherwise, I would say thanks so much, everybody, for your time. This is the end of us. I think we started this at 5 o'clock in the morning, well, 5 o'clock in the morning on Monday. So it's been a pretty mammoth effort running 3 trainings in 3 time zones across these 3 days. But I will stop there, and thanks so much, everyone, for your attention. It's been fantastic to see so many people sort of join this training event over the time, and it's been a really amazing effort as well from everyone on the team here. Thank you so much, Harry. I'll let the other folks come onto camera now and say hello. But yeah, really our sort of biggest thank you to all for everyone for your attention.
Nice. Thanks very much, Evan. It's a fitting conclusion, I think, to sort of see how Tower brings together all these different components and kind of brings all this under one roof, so to speak. Yeah, so not much to add. Thanks, Evan. Thanks, Harshal. Thanks, Marcel. Thank you, everyone, for attending. It's been a really successful 3 days. I don't know if many people realize this, but we started off organizing this thinking a handful of people might attend in preparation for the hackathon. So we might get 30 or 40 people per time zone maybe, and we ended up with over 800 total. So fantastic to see just how much interest there is out there and how much enthusiasm there is for learning Nextflow and Nfcor. And hopefully this has been a useful few days for you all. We will send out an email in the next couple of days, hopefully with a survey asking for a little bit of feedback from you guys. So if you have any suggestions about how we can improve the format, and if there's anything we can do differently or anything in the content, that would be really, really helpful. If you have anything specific, feel free to jump it into the Slack channel now as well. That'd be really, really appreciated. Otherwise, hopefully see some of you in person next week in Barcelona, see others of you online joining the summit remotely and the hackathon. And otherwise, we'll hopefully see you all on Slack soon and getting involved with the community. Thanks very much.
Thanks, folks.